Hello everyone. This is our last class related to machine learning. In this class, we'll try to learn how to analyze the classification type dataset. So initially, let's say this is our dataset. Here, temperature, dissolved oxygen value, pH, biochemical oxygen, demand, fecal nitrate, FCTC, and this is our output. From the temperature to the connectivity, this is our input column, and the last column, this is status column, shows 1 and 0. Only two type of differences has in our output or target variable. So for the column 1, the indexing value is 0, and this is column 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our target variable in 10th column, and the indexing value of 10th column is 9. We already know that from our previous classes. In status or the output column, there are two type of status, but in your analysis you can get three or four or five type of classification or differences in your output variable output column. So initially in our data set we have to classify it, how much data will be considered as a train and how much data will be considered as a test value. Let's say in our analysis 80% data considered as train data, and the remaining 20% data set is for the train data set. You can change this train and test ratio like 70 is to 30 or 90 is to 10. And here for each train value x, definitely already you have the train y value. And similarly for testing value x, you have the test value y. Let's say in this data up to 200, let's say this is our train value. So for each train value, you have the train y, and after 200, let's say 201 to the remaining portion, you have the test dataset. So for this test dataset, from column 1 to column 9, your test x value, and the column 10th value is the test y value. So you have already test y value, and for this test dataset, your model will predict test y value. And by comparing this actual y value and the test y value, we have to measure some performance measuring parameter. It may be precision or accuracy or specificity or recall or sensitivity. There are different performance measuring parameter has in our classification dataset. Let's say here this is our actual y value, and consider y equal positive, so 0 equal definitely negative. So for this actual value, our model predict actual y value also. So when your dataset first dataset actual value is y, your model also predict 1. So it's a good or a right prediction. On the other hand, here your actual value is 1, but your predicted y value is 0. So our model uh, did a mistake. Similarly, here 3 0 for our actual value, but our model predicts 1. So here also our model did some mistake. So based on this actual and predicted value, here is a matrix. As in our dataset, only two different output value has 0 and 1. So we from our analysis 2 by 2 matrix will form. But if you have three different output values, then automatically 3 by 3 confusion matrix will form. If the different is 4, then 4 by 4 matrix will form. So here is a confusion matrix. In this confusion matrix, this is the actual value and this is the predicted value. Say this is the positive value or 1, we consider for positive 1. So, and this is the predicted value for positive. So this cell is for predicted and actual positive and also predicted positive. So in our analysis, let's say here three positive value. For three positive value, we got three predicted 3 1 value. So number of case where we get for actual one, we also predicted value also one is only three. From this analysis three. So here you have to put three. On the other hand, this case is for negative or zero. This is actual zero and predicted one. So see, in actual value there is 5 0 value. Actually 5 0 output value has, but when our model predict one only three times. So here we have to put number or the case is three. Similarly, this is for positive case and negative case. Positive means one for actual case, and this is for negative or zero case for predicted case. This is known as FM type, but TN true negative cell. So similarly here, let's say negative value is zero for this cell, and here negative value is zero. So this is the known as true negative case. I mean the predicted value is actual value is zero, also the predicted value is zero. So here for actual value zero we got predicted zero, and here another for actual value zero we got predicted value zero. So there are two cases where actual and predicted both are zero, I mean false. So here we press 2. This is known as TM cell or true negative cell. This is true positive cell. This is false positive, and this is false negative. This is the um, this diagonal case is for when the actual and predicted value are same, and this is the error case where actual value 0 but predicted is 0, and this is the actual value is 1 but predicted is 0. So for calculating precision in we have to divide TP divided by TP plus FV. For this case, the TP value is 3 and divided by TP is 3, and FP is also 3. So 3 by 3 plus 3, I mean 3 by 6, this is 50% or 0.5, the precision of our model. Similarly, here is the different difference performance measuring parameter. Both value closer to 1 or 100% is best model. So here for different metrics, the formula and the base value is closer to 1, and when we can use this model. And as it is a classification model, so definitely for classification the model is different from the regression model. In our previous class we saw the different regression model term. Here for each regression model we have different classification model also, but there is only one different logistic regression. The name express it may be a regression model, but you have to careful about that. Logistic regression is a classification model. Within this model you can use hyperparameter for getting more or better result. So let's move to our code, and then we'll discuss what is ROC and ensemble model. So this is our code for classification analysis. Initially we have to connect this code and run this code individually. Let's say this is our classification analysis code. Done. Connect, then run individually all cells. So our code is connecting. Okay, it's connected. Then run all the code. Initially we have to import numpy pandas matplotlib, so cbonot something, and here is the different model with package we already imported for, because of we want to analyze using one code in different classification model. So we import all the package. Then you have to upload your dataset. Choose your file. This is our classification dataset. So we import here. Then the name you have to copy and paste here. This is a very important topic, or in our dataset, we already mentioned that we have 10 column. So first input column indexing value is 0 and the last and number of input cell is 9. So here we put 0 is for first input indexing value and the number of input column is 9, and here we have to press 9 also. This is the indexing value for output column and run this dataset. Then here we x train, x test, y train, y test we already mentioned, and here you can change random state 1 to 10 for analyze k fold, 10 fold or 5 fold. Initially you have to press here 1 2 3 dot, 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 up to 10 for analyzing 10 fold. Here is the model. This is model for logistic regression and this is our parameter. Without parameter your model will run, but if you can use proper parameter then definitely will get the best result. And for changing another model we have to change this name and the parameter also. The other thing is fully same as this code. Then run this code. Here we already after running this code we'll get accuracy, precision, recall, F1 score. This is our confusion matrix. So we got the accuracy value is 0.82, precision is 0.84, recall is 82, and F1 score is 0.82. This analysis for only considering 0, and this is 0 output, and this analysis only for 1 output, and the total output is 51 plus 28 equal 89. This is the average value, average F1 score that already initially give here. But if you want to say for the different output, I mean for 0 or 1, you can see from here. This is our confusion matrix for 61 dataset, test dataset, and for 28 test dataset, where the output is 1 and here the output is 0. And then here is another graph. It is, you can say it's a ROC curve. And to know what is ROC curve, the full form is receiver operating characteristics, and it's also one kind of performance measuring value. If AUC, area under curve, is 1, then your model is superior or best model. I mean very closer to 1, it's a good model. So from our analyze or logistic regression, we got the AUC or area under curve from this line to up to this distance is 0.9. So our ROC curve or area under curve value is 0.9. And sometimes after running the raw dataset, you can get poor results like AOC maybe 0.6 or 0.5. At that time, you can use feature optimization technique same as the regression analysis and see how AUC or accuracy value or F1 score you will get. If it's better, it's okay. But after applying feature optimization technique, you get the poor score, then definitely you have to ensemble model. Ensemble model means you have to merge multiple model. There are different ensemble model has. One is bagging, boosting, voting, staking. This at the different model you can apply for improving your dataset. And from our one or single dataset, we get the F1 score is accuracy is 0.82. I mean 82%. But here is another curve or another code has. Here we use voting classifier. This is one kind of ensemble model. And after running ensemble, we ensemble here 3 model like logistic regression, random forest classifier, and support vector classifier or support vector machine, you can say also. So we ensemble or we merge 3 model here, and let's say see what is the result or accuracy value. Here the accuracy is 88%, but when you apply only single model at the time, you got accuracy 82%. So definitely if you can ensemble different model, then you will get better result. And here the AUC value also, though the AUC value is same as previous manner, but our accuracy will improve after applying Ensemble model. So here uh, is the full classification analysis, and you can apply the explainable AI, I mean shape or line figure in our previous code when we analyze or discuss regression analysis. At that time, we share already the code for shape and line. Similarly, you can apply shape and line for classification also in dataset also. So thank you, everyone. If you need the code, leave a comment. I will try to send you through your comment section.